Okay, so our next speaker is Tipton. Hopefully, oh, you're up there as Tip Hudson. Hi there. So he's going to talk about, hopefully, yes, is going to talk about data-driven dynamic grazing decisions for increasingly variable landscapes. So welcome.
I was going to say good evening, but I'm not sure what time it is where you are. In Washington State, it's a little past my bedtime. I am from Washington State University. We're on the northwest coast of the United States, and I would have enjoyed being with you in person, but not this year. I'd like to talk about some concepts behind the creation of a grazing decision support tool that is now under development that I believe will be of use in any grazed ecosystem, but especially in arid and semi-arid ecosystems. I do think it's useful to offer just a brief definition of rangelands, which are the primary target areas for the decision supports tool. Nathan Sayre, in an excellent 2017 book titled Politics of Scale, A History of Rangeland Science, says that rangelands are almost more like oceans than croplands or forest. They are vast and variable, and they resist micromanagement. So we historically defined rangelands by everything that they were not. Today we define rangelands as being plant communities that are dominated by grasses, grass-likes, forbs, and shrubs, and typically also are managed as a natural ecosystem as opposed to an agricultural ecosystem. And because restoration of rangelands is typically expensive and not guaranteed to succeed, it's pretty important to prevent rangelands from crossing ecological thresholds into degraded stable states before that restoration is needed. The idea behind this decision support tool addresses this challenge of informing what levels of harvest, such as from grazing, are sustainable, because there are so many factors involved, many of which are outside human control. And I would mention that 2026 is tentatively planned to be the International Year of Rangelands and Pastoralists as part of the decade of ecosystem restoration. One of these uncontrollable factors in rangeland community dynamics is precipitation, which is usually the limiting factor to plant growth in semi-arid ecosystems. Ecological research over the last 50 years has identified this year-to-year variation in the amounts of precipitation as being one of the driving factors in changes in plant communities, and that most importantly, this variability is more significant than aridity. Here's an example of the amount of variation in a 40-year stretch. This is some satellite data showing rangeland forage production in the western United States. For those who are more familiar with kilograms per hectare, which is probably everybody except me, that conversion is 1.12. So 1,000 pounds to the acre on the y-axis here corresponds to 1,120 kilograms per hectare. This illustrates a couple of things. One, it seems that this amount of year-to-year variation is increasing, and two, the magnitude of the variation is quite large, varying from somewhere around 700 pounds to the acre all the way up to nearly 2,500 pounds to the acre. Those are large differences that are difficult to accommodate with what have historically been static stalking rates in the United States. The difference between the highs and the lows are quite large. One of the things that has changed in range ecologists' understanding of plant communities in the last 100 years is that in particular, the federal and state grazing allotments were based on static stalking rates. This came from some ideas advanced by a professor named Clements who came up with the idea of climax plant communities. The idea that if we succession works like a spring, and if we just leave something alone for long enough, it'll release pressure on the spring, and the plant community will move back toward a climax state. This is likely not new news to anybody on the on this meeting, but there's a couple of reasons why fixed stalking rates are not a good idea in nearly any semi-arid ecosystem. The first is what we've already discussed, that environmental variability is the norm. The second is that this Clementsian model assumed that any ecosystem would move toward the climax plant community if we removed the disturbances that caused it to become degraded. If those disturbances were removed, it would snap back like a spring to that climax plant community. But these rangeland landscapes are notoriously heterogeneous spatially as well as temporally, and historical ground-based range surveys really have not been able to account for this diversity with any kind of accuracy. It's simply not possible to use ground sampling techniques to adequately measure annual net primary production in any meaningful way across a large landscape that is so variable. So we have some competing values. First, the stalking rate, or the amount of land that's allocated per animal, has been held up as a primary factor in the long-term health of grazed rangelands, and I think that's probably still accurate. But getting this stalking rate right, or hitting some range that we could say is sustainable, assumes some predictability in forage production and ensuring that animal demand for forage doesn't exceed the landscape's supply of forage, not just for livestock, but for the other ecological processes that stabilize soil, maintain water cycling, and provide for wildlife habitat. But then second, there's significant variability in forage supply that is difficult to accommodate unless we set a stalking rate that only matches the lowest forage production years. The stalking rate does matter, but it needs to not be static. But most ranchers don't want the uncertainty of a variable stalking rate. The group that I'm working with received a grant from the United States National Institute for Food and Agriculture to build this decision support tool based on a concept identified in the Rangelands Journal, an article that we put out a couple months ago. We identify some of the problems associated with having a stalking rate that that is mismatched with forage supply in various ways. And I think we won't take the time to walk through some of those right now. The goal isn't necessarily to apply the same ratio of animal demand to forage supply or the same stalking pressure evenly everywhere, because this variation in grazing pressure across space and time is interacting with disturbance regimes to generate valuable species diversity, plant community structural diversity, heterogeneous patterns of plant community types. Sam Fuhlendorf, who's written quite a bit about the value of heterogeneity, has said that 6 patches make you 6 times less likely to be entirely wrong. It'll make sense in about an hour. The idea here is that we don't necessarily want to apply grazing in a way that creates uniformity of plant community types across a landscape, but to allow the natural variation and also to create some variation through grazing pressure interacting with natural disturbances and plant communities. But no matter what we want to attempt to allow in terms of natural processes or attempt to create in terms of deliberate patterns of use for specific ecological objectives, it's first necessary to have reliable information about the landscape's plant community and the variation in forage production over time. So the idea with a decision support tool is to use satellite-derived data such as NDVI that's been mentioned already to be able to more accurately quantify forage production in the landscape. That's not necessarily a new idea, but today we have multiple sources of forage production data, and then specifically the decision support tool will be designed to try to incorporate animal behavior and animal behavior interactions with the landscape in a way that's context specific and can be defined by the user. So there are a number of data sets now available that provide annual net primary production and various supporting values such as cover types and in some cases species composition from regularly collected satellite data. The other big change is that we now have that data at fine enough spatial scales to be relevant to a single landowner or a single grazing area. And to engage with animal response to the landscape, there will be a number of user inputs as part of this DST that help to define animal behavior specific to a given context. So I guess to summarize the functionality that we're working to create, the system will collect estimates of above ground forage production and allow users to visualize the spatial patterns and temporal trends of forage production for an identified area of interest. The system will also allow users to spatially define parameters for terrain use by livestock, such as slope and distance to water, the harvest coefficient, or the percentage of annual net primary production that we want to consider available to livestock for the purposes of calculation, and some other non-stalking rate management factors, and then combine these elements into a stalking rate equation, producing spatially explicit and aggregate values annually from 1984 to the present, to be able to visualize that diversity in the stalking rate values. I think so. The final product of this decision support tool would be a map that shows these stalking rates over time with the user inputs shown in there. So for example, one of the potential functionalities could be if there's a 50,000 hectare grazing allotment, a permit area, and there are 10 known water locations, and a rancher is trying to determine how much additional grazing area could be made available by the installation of a water tank in a particular location. The system would allow a person to see how much additional forage would become available through putting a stock tank in an area that might draw use away from more heavily used areas. It also, of course, allows one to see how much variation in forage availability over time, including the relative suitability of a given site for grazing, or inversely unsuitability for grazing from a variety of factors. As part of the grant, the NIFA grant that's funding the work, we have promised the direct involvement of at least 3 rangeland sites across the western US with known long-term sustainable stalking rates and mature grazing programs. And these will be used to beta test and fine-tune the tool. But the team's intent is to work more broadly than that. And I would be interested in identifying an international partner or two in places, again, where there's enough history of grazing to know that the current approach or the historical approach has been sustainable. And so those values can be compared against the values that are generated by this tool once we get it going. For those that are interested, I want to mention that we completed a couple of years ago some short film documentaries that illustrate 3 different aspects of rangeland management resilience among mostly ranchers in Washington, Oregon, and Idaho. So we highlighted 3 different ranchers that approach this in different ways, and some of these will be used as part of this tool development. And while we're here, I want to mention that about 2 years ago, I started a podcast called The Art of Range. The idea was to interview experts in the world of rangeland-based livestock production and rangeland ecology, and broadcast that information to people who make a living making good decisions on rangelands. And I wanted to be sure we left a little time for questions, since I'm probably I'm kind of the odd man out in this group. So that is all I have.
All right, thank you so much, Tib. We have a few people here. I'll just see if they want to ask any questions. Are there any questions from people in the audience? Yeah, we've got one. I'll just give them the mic.
Yeah, thanks for that talk. It's really interesting. Is it on?
I can hear you.
Okay, great. You just mentioned there that you're looking for international collaborators. Is that for testing that tool on, say,
Correct.
existing properties in other parts of the world in different systems?
Yes.
Yeah,
we expect the project will initiate here in about 2 months, and we expect that within about 9 to 12 months we will have enough of a beta product ready to begin testing it in some areas, and it would be useful for us to test it in some places that are, plant communities that are different than what we have in the Western US.
So what exactly would you be looking for in terms of properties, or as a suitable place?
Yeah, I would say something large enough that the data would be meaningful. I guess, if a property was 10 hectares, that probably would not be large enough to, to visualize the data very well. But a larger site than that has, a shrubland, grassland, savanna plant community, and specifically for my purposes, I'm not the data guy. I'm the range livestock guy. And from my perspective, it would be most useful to have places where there is a history of grazing management that has been sustainable. And by sustainable, I mean that it has maintained a desirable plant community, maintained soil stability, and hydrologic function for a long enough period of time to know that the grazing program is sustainable. That will allow us, to calibrate known stalking values against the stalking rates that are calculated by the tool using satellite imagery.
All right, great. I might have a property and a grazier in mind, and I'll pass your information on.
Yeah, that'd be wonderful.
He also used to be the chairman of the South Australian Pastoral Board, so he might have other contacts as well.
Great, thank you.
That's pretty much all semi-arid shrublands and all grasslands.
Yeah.